Our next speaker is Dr. Chad Engelland, Professor of Philosophy at University of Dallas. Dr. Engelland works in phenomenology. He published books on ostension and transcendence. The book Ostension, Word Learning, and the Embodied Mind. Heidegger's Shadow, Husserl, Kant, and the Transcendental Turn, and Heidegger on Transcendence. In addition to these publications, Dr. Chad Engelland is also publishing quite a lot on AI in journals of general audience, and the last piece I have seen is now published on the website of the Department of Education. So please join me in welcoming Dr. Chad Engelland.
Thank you, Mirella, for that for the invitation and for that introduction. Very happy to be with you here at the University of St. Thomas for this conference, and I'm in the midst of teaching a class on philosophy of AI, and I'm really just excited for this opportunity to think alongside my students and to think alongside you. This is an issue that we're all trying to catch up to in thought. The title of my talk is The Language of AI, and the subtitle is Generative AI as Repurposed, Expropriated Speech. Writing last week in Nature, 4 authors, 2 philosophers and 2 scientists, proclaimed the fulfillment of Alan Turing's dream of bringing about machines with general intelligence. Their argument was that our machines have passed benchmarks in every area you could wish. While their intelligence is alien, it is nonetheless genuine. Hence, they conclude that our machines have minds that displace the human mind as the bearer of the only kind of mind under the sun. While there is much to think about regarding their paper, I would like to focus on a concluding sentence, and I quote, "General intelligence can indeed emerge from simple learning rules applied at scale to patterns latent in human language, patterns rich enough, it turns out, to encode much of the structure of reality itself." End quote. That sentence captures precisely what I find fascinating about AI and also what I think they misunderstand about it. Precisely because the intelligence exhibited by AI is derived from human language that encodes reality, it is not a rival intelligence or alien intelligence. All the intelligence in artificial intelligence is human intelligence. We can point to a book or an entire library and see intelligence on display, but the intelligence points to the individual acts of understanding of the author or authors. The books themselves are not minds, but products of minds, and they need to be decoded by minds for that intelligence to surface. A book is not a collection of words, but instead a code of expressed thoughts. The book points back to the author. In what follows, I employ the resources of the philosophy and phenomenology of language to investigate what large language models are. I will argue that generative AI is expropriated speech, encoded, processed, and decoded, that personifies its bearer in such a way that the real speakers are occluded and made into ventriloquists hidden from view. The speaker of the chatbot is not the chatbot, but a composite of the many voices echoed, integrated, and harmonized through the refinement of these engines of prediction. The language of AI is borrowed language. Keeping that constantly in mind is key to keeping us from losing our footing in the face of such wild claims. My first section is entitled Presence and Absence in Speaking and Writing. For something to be both said and heard, speaker and hearer must be present to one another, even should one or the other be veiled, as in the case of a hidden speaker, a ventriloquist, or a hidden hearer, an eavesdropper. John's utterance, the tower bell's toll, will not be heard by Margaret if she's not in earshot. Joint presence is a necessary condition for the human conversation, and of course, it forms the sole basis of oral cultures. But writing upsets the necessity of joint presence by introducing the possibility of absence for the speaker to the reader. A slip of paper on which is written, "The tower bell's toll," can occlude both the writer and the speaker from each other. The writer may write just for himself or with someone else in mind, but the paper slips out of his possession and is read by a passerby who knows not who wrote it. Or published books are, as it were, a message in a bottle carried by the current to whomever happens upon it. In this case, both writer and reader can be veiled to one another. It is important to add as well that written books take on a kind of identity of their own. It is true that in an oral culture, a story like the Iliad can emerge that is independent of given conversations, being something we can return to again and again. But when it becomes written down, it subtly but profoundly shifts from a story that is retold to a story that has been told. In that way, it acquires a kind of independence vis-a-vis the reader who becomes the speaker. With orality, the speaker speaks and the hearer hears. With literacy, the reader lends his or her voice to the absent author, who in effect delivers to the reader a script to be read. So, for example, to read The AI Mirror by Shannon Valor is to lend one's own voice to the author, who then speaks again through that lent voice. The reader both generates the oral version of the scripted text by following the text and hears the generated text. That is, all hearing is oral. All speaking, even all writing, is oral. The writing bears the spoken word but does not substitute for it. The writing was generated by orality, whether voiced externally or merely internally, and it can only be heard by being returned to the heard word, whether voiced externally or merely internally. Writing is itself a kind of code, which as a code carries hidden meaning. The letters on the page are meaningless as shapes of ink or pixels, yet in certain combinations, they can provoke us, the reader, to make out sounds, the sounding of which are spoken words. Elementally and mysteriously, the spoken word carries meaning for speaker and hearer alike. The written word is therefore derivative of the spoken word. It is not coded thought, but coded speech. And the spoken word is not itself a code. It does not code, but instead expresses thought. To read is to decode the written characters to know which words are to be said. Every text is essentially a coded script, the decoding of which allows us to lend to the absent author our own voice so that the author's thoughts might again be expressed. According to speech act theory, there's a difference between a locutionary act, whereby a sentence is spoken or produced, and an elocutionary act, whereby a sentence is meant. When we read, in virtue of following the script for generating the locutionary act, the author's elocutionary act can again be heard. But the text only encodes the locutionary act, not the elocutionary act. The page tells us what to say, but not what it means. There is thus something purely mechanical about reading, but also something that clearly exceeds the limits of the mechanical as well. According to phenomenology, the expression not only expresses, it also indicates the thinker's activity of thinking. Hence, when we read a text, we have continuously indicated to us the thought that informed the coded words on the page. Section 2, ventriloquism and the personification of the bearer. The written word, with its own identity vis-a-vis the writer and the hearer, can transcend the context intended by the writer, and it can wholly occlude the writer for the reader. This can amount merely to reification, or in some cases, personification. In the case of reification, the reader attributes the texts read to a single author, even if there were many authors involved. You might say something like, according to the Stanford Encyclopedia of Philosophy, the figures of the Enlightenment excelled at one kind of explanation and were deficient in others. The single author or the various authors of the entries disappear behind the mantle of the one encyclopedia. Other expressions repeat the same logic. We say, according to the dictionary, according to Wikipedia, according to the New York Times, and so on. The text can be reified so that its author or authors drop out as speakers, and the voice is that of an impersonal but authoritative generative entity. Yet expropriated speech, with its own identity vis-a-vis the writer and hearer, can transcend the context, not only by reifying, but also by personifying the bearer. It can seem, but merely seem, that the bearer is the one that speaks. So at Olympia, you can go to Olympia in Greece to this day and see this very example. A cup was found that has etched on its base, I am Phidias's. It was found near the sculptor Phidias's studio. And that I am Phidias's is a message it repeats tirelessly to all that come upon it. Outside Waco, Texas, a billboard proclaims, "Use me!" exclamation point. It's advertising by speech projected upon a personified bearer of the message. A piece of paper on which is written, "I am your friend," seems to be merely the bearer of someone else's message. But if that same paper is affixed to a likeness of the sort of thing that could be a friend, say a child's stuffed animal, then we are speaking of a projective personification. The author of the cups, billboards, or teddy bear's text has practiced the art of ventriloquism. That is, thanks to the expropriative character of writing, Phidias has projected his voice so that it seems to be coming from the cup, as though the cup as bearer of the text is the speaker of the text. There would be no seeming if it were merely written down on a piece of papyrus, for we regard such things as paper to be nothing more than neutral media for presenting to us the words of another. A thing, by contrast, is something more than a neutral medium, so susceptible to the art of personification and ventriloquism. Ventriloquism or displaced speaking can be transparent or opaque. In the case of a sound system, we naturally ascribe the sounds coming from the electronic speakers above us to the human speaker whose mouth is moving at the podium below us. But we can also hear the speech and think, as it were, imagine that the speakers themselves are the ones doing the speaking. We can watch also a traditional ventriloquist act and follow the seeming of the dummies talking, or we can shift to the being of the ventriloquists talking. We can shift back and forth. We have the freedom to attend to the one or the other, the seeming or the being. What does this have to do with AI? Section 3, the case of generative AI. The machine presents speech, but does it speak? The book presents speech, but does it speak? When the chatbot emits speech, how should we understand it? Well, first let me untangle its seeming. This is a case of written speech in which the speaker is hidden. Therefore, it is expropriated speech. Because it emits this speech in response to my question, it seems to be addressed to me by its bearer. The machine that bears the message seems to be my interlocutor. This follows the logic of ventriloquism. The cup or the billboard seems to speak as the bearer of the expropriated speech. The dumb bearer appears to talk. Second, let me untangle its being. In the case of the cup, it is obviously not the one really speaking. The billboard is obviously not really the one that wants us to use it. The teddy bear is obviously not begging to be bought. There is a touch of humor. It is a joke that only a fool would take seriously. Why regard AI as in any way different from the other cases of expropriated speech? The obvious answer is that AI doesn't just say the same thing to all. Phidias's mug, Waco's billboard, and the stuffed animal just say the same thing, like Kierkegaard's madman who only said over and over again, "The earth is round," to one and all. Intelligence is adaptive, responsive, and variegated. AI hears, AI processes, and AI responds interestingly and usefully. It is expropriated speech. It is a special case of adapted expropriation. Section 4, whence generative AI? Unlike the ordinary cases of expropriated and personified speech, AI is not scripted. It is a result instead of machine ingestion. Rather than writing a rule book of responses to every possible question, the AI machine was programmed to analyze a dizzying number of speech acts and discover numerical patterns attached to words so that, given what has gone before, it can predict which words are to come next. It then can string together words based upon these patterns of probabilities. The result is that when a chatbot emits speech, it is producing something that no one has ever said verbatim before, based upon its attempts to catch up to the puzzling things people have actually said. And this originality seems to be part of what contributes to its credibility as a speaker, as something that appears genuinely intelligent in its own right. In the training phase, the large language model harvests the human conversation by converting conversations into mathematical probabilities. The processing of words happens through the substitution of the mathematical relation for the qualitative one, a substitution that tracks the identity without embodying the meaning. Again, the chatbot is a predictive machine that can guess what comes next based upon what came before. Yet one has to recall that it does not discover, but in fact paraphrases by means of averaging together the patterns of meaning embedded in the elements of multiple speech acts. Hence, what it does in response to a question is respond by imitating how the speakers in its database were likely to respond. And let us remember, this database is full of expropriated speech. The query reveals the process of polling the expropriated speakers through the medium of their expropriated speech. The machine does so not by asking them a question, but by quantifying the results and predicting the future of their locutionary acts. The illocutionary acts that undergird them are beyond the reach of the quantification, but are nonetheless encoded in them. The computer's code captures the human written code, and in so doing, codes the speech, but only we can hear the coded speech as speech and not as code. The computer produces the mechanical aspect of speech, something for us that is inseparable from the expressive side. Hence, it seems that the computer that generates must be one that understands. The point could be put as follows. One cannot learn one's mother tongue by learning to read, for learning to read is just to decode certain marks in terms of certain sounds. But the production of certain sounds is not speaking. The computer only knows how to read, how to sound out words, not how to speak. Searle argued famously that the agent in the Chinese room thought experiment could generate Chinese without knowing Chinese, a conclusion that seemed plausible when it merely followed a rule book scripted for it by its programmers. But in the age of so-called machine learning, in which the machine is programmed to scrape and analyze data and thereby formulate its own rules, the answer seems otherwise. But in light of the above analysis, we can restate Searle and see that the original conclusion remains. If I in my room merely chart mathematical relations among millions of Chinese words and build my own rule book that I follow, I still don't have any way of knowing Chinese. It remains a code bereft of semantics. And this for the simple reason that you cannot learn to speak by learning to read. Sounding out the words is no way to learn that or how they express things. What the chatbot originates then is a composite text that presents in coded form the judgments, discoveries, and thoughts of many hidden writers it paraphrases. Because we can not only read but also speak, we can see these judgments, discoveries, and thoughts as judgments, discoveries, and thoughts. We are astounded at its speed, but that is because it does not have to think. There's no discursivity crowned by intellection. Instead, there is a calculation. Your question has a numerical pattern of probable connectives which interfaces with its proprietary algorithm and the probabilities of its acquired data set to spit out a jumble of numbers. True, those numbers correspond to words that are arranged in ways that we can see are meaningful. But all meaning is parasitic upon the speakers whose acts of speech were analyzed during the learning phase of the machines being built. The intelligence is expropriated, but not appropriated, coded and processed, but not understood. Generative AI, then, is a mechanical means of presenting intercalated and averaged thought drawn from expropriated texts, written by absent speakers, and presented as the sort of things these speakers might say were you to ask them. Section 5 has a big title, The Being of AI, but well, maybe it should be toned down a bit. We're trying to make some suggestions toward the being of AI. The medieval philosopher-theologian Thomas Aquinas had his secretaries create slips of paper on which were written passages of Aristotle's Ethics that would be relevant for Thomas when writing his masterwork of theological ethics, the Summa Theologiae. What the AI trainers did was analogous, but on a truly ambitious scale, to take countless books and countless speech acts and index them by identifying an underlying numerical pattern that expresses the relation among its words and thoughts. Again, the large language model is not about the past, but trained on the past, it predicts what people might say on a topic. When we prompt the bot, it shuffles the cards, merges or averages out the relevant ones to present a composite voice. So, for example, my book on ostension was fed to Anthropic's Claude. I know this because I'm part of a copyright settlement. The book was on how human children learn to speak on the basis of embodiment. Suppose someone asked about the role of ostension in first word learning. Claude would take what Wittgenstein and Quine wrote and merge what Engelland writes to find the most probable patterns of word proximities. Actuality proves possibility, and accumulated actualities prove probabilities. The predictive machine predicts the future by measuring itself against the past and these past authors. What is really remarkable then about machine learning is its programmed ability to take coded qualitative inputs, such as analyses of the way the body makes joint attention possible prior to speech, as I wrote about in the book Ostension. Convert those into quantitative patterns of probabilities, merge those probabilities with quantitative patterns of other inputs from other books, and generate a stable pattern that can, thanks to the input of a qualitative input, that it converts into a quantitative pattern of probability, be used to output a quantitative pattern of probability which corresponds to a qualitative pattern of meaning that we can understand. This is the real genius of machine learning, to take that which a machine cannot understand or process, convert it to something that corresponds with it, that the machine can process this corresponding cipher, and then convert it back to something it cannot understand, but that can be understood by us. To have found that the mathematical patterns of expropriated speech encode its thought, that this thought can therefore be averaged out and processed, that is the wonder of machine learning. If generative artificial intelligence is expropriated speech, then all its intelligence is natural human intelligence, derived from the speakers that inform the data set and the present user. Thus, instead of calling artificial intelligence artificial, it would be more accurate to call it expropriated natural intelligence. For its appearance of intelligence is parasitic upon the natural intelligence that is embedded in the expropriated speech it analyzes. Now, what is the difference between the way the chatbot writes and any human being does? For the human author writes only after having read a lot of books. The difference is that the author does not transcribe the patterns of meaning into ciphers. The author instead retains the voices of these other authors as so many claims about the way things are. The author then checks these various claims against how things appear to the author, checks the various voices against the truth of the matter. Then the author endeavors to say what he says while also responding to these other voices. In this way, the author has interlocutors and has to be responsive to the truth of things. The author does not always say something new, but often will just, through the act of appropriation, repeat what has been said before and take a new ownership for it. The bot, however, listens without being able to grapple with how things appear. The fundamental act of authorship is appropriation. Other authors benefit our seeing, or they are introduced as interlocutors. Section 6, learning versus training. One can be trained to handle a code in its coded form. Such training involves exemplification, rule promulgation, and inevitable correction. Children, for example, are trained in grammar. Why one says Sophia and I instead of I and Sophia is something that has to be learned by rote. But the uptake of semantics and fundamental grammar is not a matter of training. It is co-natural, acquired but not artificial. Its principles are divined. Wittgenstein thinks of children learning the first words as though they were children learning the fine points of grammar. Augustine, however, realizes that children are not cracking the code of language, but instead decoding the ciphers of speech in terms of the things meant. Large language models are rightly said to be trained. They are rightly said to be fed. Their uptake of speech differs fundamentally from children insofar as bots do not crack the code, but merely learn to handle it. The children, however, are natural decoders, thanks to the living language of the flesh. What remains the enigma to the machine is perfectly natural to the human, flesh and its affects. Searle's thought experiment shows that the computer, qua computer, that is, qua one that merely computes, merely calculates, deals with codes as codes. The code remains encoded. The cipher remains a cipher. That is to say, to the machine, a zero, a nothing, just something to be computed or put together. Language is a system of signs that make manifest. A code is a system of signs that does not make manifest. Language can be treated as a code. When so treated, it does not express. And yet the expression can be carried by the code and reactivated as expression by a language speaker who knows the language. Spoken language is a code to the outsider, but it can be naturally decoded thanks to the natural language of the flesh, that is, the naturally disclosive power of the flesh to make manifest our effects and thereby to highlight the intelligibility of things. While machine learning is therefore a contradiction, machine training is very much a possibility and indeed a reality. Section 7, a bit more about codes. As is well known, Turing worked in World War II on the task of deciphering the Nazi code machine called Enigma. That machine consisted of gears and wires that scrambled communications letter by letter in a different way each day. Turing and his team built digital computers to imitate the machine and thereby hasten the daily task of deciphering the variable machine and its messages. Now, when they were successful, they took a coded message, let's call it the coded artificial language Enigma, and were able to decipher it letter by letter into written German. For a German speaker, written German is a code for speaking German. For the English decoders that didn't know German, transcribing Enigma into written German, the code is doubly coded. It was necessary then further to sound out the German and then translate its expression into English. What machine training and large language models, in effect, have achieved is to analyze millions of coded messages spoken and posted by the foreign or enemy humans. Here I intend no hostility, but merely the alienness or foreignness of human speech. For simplicity, let's say everything on the internet and in the training set was in English. The machines analyze these speech acts as essentially the same as Enigma. That is, as meaningless string of letters that stand for something, it just doesn't know what. It first transcribed these letters into numbers and then analyzed the relations between the numbers. What the machines did, and this is truly remarkable, is to map by modeling the mathematical relations among these numbered strings of letters. large language models do not crack the code in the way that a member of Turing's team could crack Enigma and understand the German or equivalent English sentences. On the strengths of its mind-boggling survey and analyses, the machine is able to create new coded messages easily and seamlessly about anything that is present in all of its training data. What the simulator does is analyze code and, without being able to understand it as an expression, generate new variations of code combinations that are meaningful when decoded by us. It is as though the Allies in World War II were not able to break the Nazi Enigma code, but were able to generate new coded messages that were perfectly intelligible and sensible to the Germans. Looking at these messages, the Germans might have concluded, they've cracked the code. Look, they're speaking to us in Enigma. But in fact, that would be an erroneous inference. To generate Enigma, it is not necessary to understand a word of what it expresses, because what Enigma is the quantification of what's left once expression has been bracketed and set aside. I come then to the conclusion. And I ask for your indulgence, for I am going to end with a thought experiment, which, as you know, has sort of a accompanied philosophy of AI from Turing through Searle. So take two pairs of twins. One is a set of human twins, and the other a set of machine twins. For the purposes of this thought experiment, we will stipulate that both pairs of twins are placed in identical learning environments. Everything the human twin sees, the other sees, and so on. Every bit of data fed to the machine twin is fed to the other, and so on. The random element of machine learning is put in sync with the random element of the other. You can do that. At the end of education, compare both sets. The machine twins have identical architecture. They have identical data sets. They will have identical underlying weights. Ask any question of each, and their answers will be identical word for word. Expropriated texts remain expropriated. The human twins will no doubt have similar beliefs. They are genetically identical and share the same experiences of the world. Nonetheless, they will not answer each question identical word for word. Even though their biology and environments were the same, they had to understand for themselves. And the insights they have are not attached to language. They are able to express them using different words. Expropriated texts have been, in their cases, appropriated. I conclude that the machine twins mechanically reflect the coded intelligence present in their data sets, but the human twins, just to do what they do, must appropriate both the speaking and, separately, the knowledge available. The latter is something that is not predetermined, but the result of personal acts of understanding that may or may not be linguistically formulated. To return to the quotation with which we began, language does indeed encode an understanding of reality, because language speakers have expropriated their understanding through writing. To learn from AI machines is to learn from the speakers whose insights are harvested and made available by the mathematized model of all that has been said, and hence all that might be said again, albeit in different ways. With AI, there are not more minds, but the same human minds made available in new ways. Humans have not been supplanted, but their libraries have been organized and made immediately accessible in a nuanced and surprising way. Thank you.
Hi, thank you very much for your presentation. My name is Diane, I'm an alumni. So I have experience with instructional design and e-learning, where I've actually created voiceovers and edited my own voice. One challenge that I recently came across was actually using Adobe products and voice editing software to actually do the same with an AI-generated voice. And because I had the editing experience for several years, I was able to complete it successfully, complete the project successfully. However, sometimes it was challenging because you would want the, say, for example, say Lionel Bissell. Trying to get the AI-generated voice to say that was interesting. Or saying like record versus record, that type of thing. So there were some challenges with it, but I just was curious when you were talking about speech and language. Just wanted to share this comment experience. Thank you.
Oh, yeah. Thank you. I had to cancel class today, so I recorded this talk and had my philosophy of AI students listen to it. And of course, the temptation for them is going to be to play it back at double the speed, or maybe even triple, right? But that might inhibit the uptake. But that's part of the challenge. Is you can take in human speech you have a locutionary act and the elocutionary act, and if we hear it at normal speed, we can follow the meaning behind it, the elocutionary acts. But on double speed or triple speed, if someone's talking about something interesting, that is to say something that requires some thoughtfulness to follow, then that's going to fall out. So, I mean, that's something that comes to mind just based upon the challenges of e-learning and the kinds of things that we have to sort of deal with both on the production side and the reception side.
Yes, I had to be very creative and also add pauses. It actually took longer for me to do it with AI versus if I did it myself. But that's only based on my experience because I had a lot of experience with editing. But anyway, just wanted to share.
Thank you.
Thank you very much, Dr. I have a question about your thought. I have a question about your thought experiment.
Yeah.
If I heard you, the machine twins would give word-for-word responses, I think is what you said, word-for-word, the same response.
I did say that, yeah.
Yeah. That's not, I'm not convinced by that, so maybe you could convince me.
Well, of course, part of generative AI is to have a random element added, but the random element can be stipulated, right? So they could be stipulated to be the same. My computer science friend tells me, I think describe this as seeds. So you have the same seed in both. So you could stipulate that. Whereas it's not just an issue on the human side of a random element. It's this other side of actually the appropriation, of having to pay attention, registering the truth. So I think when we want to kind of neutralize the appearance that these machines are actually appropriating, I think seeing the fact that they are merely mirroring back to us their data set, and to say that that's done mechanically because you could instantiate the same mirror in two machines, that I think is helpful. That was the idea of the thought experiment.
Okay. Because the many AIs, I can just ask it the question again. Well, I mean, we probably would be, I'll ask you later maybe some of the.
Sure, yeah, I mean, they are designed to have that random element, but the random element is mathematically defined, right? So it's, so it can be stipulated.
I think there's more than the random element and the random seeding.
Yeah.
Number one, they put a lot of effort into making sure it's truly random and not sort of a human randomness. But the other thing is there's a numerical diffusion that occurs as these algorithms run. And even in a prescriptive 30 years ago, I remember watching someone give a talk on looking at effluents going through soil to remove contaminants. And they could start with and this is not AI, this was a purely predictive mathematical model, and one run to the next did not generate the same flow through the soil because computers have a limited amount of resolution that they can handle, and the differences in this diffusion occurred sort of at the edges of the model. And I'm sure AI has the same kind of mathematical deficiencies that will generate. Absolutely. Or not even how, but it's at the limit of the rounding error, and that diffusion comes through. So I tend to agree with the previous speakers. There's probably no way to get identical answers.
Even if they were fed identical data sets?
That's exactly, from 30 years ago, it was an identical data set. Not to get too much into the detail, but water was put over the field. There were production wells to carry this contaminant through. 100% identical inputs, and the computer model could not. The average result at the end was the same,
But my question, though, is really if you had two identical computer models.
No, it can't be done. It's at the limit of computational science. Once you put it in.
No, but you're comparing the model against reality. I'm just comparing two models against each other.
I'm comparing the exact same model, run and run again and run again and run again, with no changes to inputs, no changes to boundary conditions, no changes to initial conditions,
Okay.
and it can't generate the same dynamic result. It generates the same average result, but the details coming through, not the same.
Okay, thank you.
So I'm inclined to accept your point about the stipulation of randomness because even when we're talking about floating point errors, we can still do it in a virtual machine or something and make that work out. But I guess I'm wondering about the other direction, whether just the fact that we get a kind of result that is 100% predictable means that it's somehow thereby merely expropriated speech. So the example that I have is, so say that you and Robert and I were asked to vote on who is the most influential philosopher of the 20th century, the most important. And maybe you say Heidegger, and I say Lonergan, and I don't know, who you...
Well, who else but me?
Okay, yeah, and Robert puts in himself, right, okay, fine. So, but I really don't like Heidegger, and so whatever. So we're doing like a ranked choice, and we end up settling on David Lewis, right? Who none of us individually would have said, yeah, this is the most important philosopher of the 20th century, right? It's not expropriated speech of any of us, and yet. Even though we each submit our ballots, a machine or a person who speaks very little English and has had no philosophy classes could tot them up and say, aha, David Lewis comes first in the ranked choice competition, and read, your committee has selected David Lewis. But it doesn't seem like that would be, even though it's a totally deterministic process given the three of our inputs, it doesn't seem like it's expropriated speech from any one of the three of us.
Well, I mean, just to get to David Lewis as an option, you would have to, that would have to be part of the data set, and so the averaging out, so the acts of intelligence in which he would be counted as a major thinker to begin with would be included there. So I did.
He's the greatest.
Oh, I see. So I would say in some ways then no one is making that judgment that he is the greatest. So you're, okay, so that's a good question. No one is. And I think in that respect, what we have here then is the averaged. It's sort of what one says is not what any one in particular says. And so what we have here is a voice that we are all contributing to, but not any one representing. So I do think that there is it's an expropriated voice, but it's not a particular expropriated voice. It's a generalized expropriated voice. And we say all the time what one says. Heidegger, by the way, makes much of this, das Man. And I think that an averaged out account is precisely what we would arrive at if actually you were going to put forward David Lewis as the greatest philosopher. So that's, I guess it is important to realize that the human intelligence can have a kind of corporate character to it. It doesn't have to be that the intelligence is an individual, but the point is, though, the corporate character is actually composed of and a reflection of all of the individual participants in it.
I really enjoyed that. Thank you very much. And I find it extremely persuasive. And I'm actually teaching right now a group of computer science students, and I really wish they would find it as persuasive as I do. Here's something I think that they are going to say, and I'm just going to see if I can get a better answer from you than I would give. So they would say, well, when you said that we don't have to decode it into something mathematical ourselves. We don't do like a machine does, translate it into something we don't understand, like mathematical weightings. I think that they're going to say something like, well, actually we do. That's what our brain does. And so these neural networks are based on what we're supposedly doing with our brains. And not on the conscious level, of course, does it seem that way. But nonetheless, we are ultimately doing the same sort of thing. So just, I think that's what they're going to say. So what would you like to say in response?
I might say, read my book on phenomenology, right? So that's probably what I would say. But I think in some ways what has happened and what we're seeing is such an impoverished understanding of human experience is available to us today that we actually are ill-equipped to conceptually combat this imitation of intelligence or expropriated intelligence. And so I think it's, in some respects, I mean, one positive aspect to this development is that we cannot fail to reclaim the reach of human experience and to enter more deeply into the claim of truth upon us and come to terms with what it is to be a human being, not as something that's happening in our heads, but something instead that involves the interpersonal encounter and community and things like shared meals, like thankfully we'll be enjoying here in a minute, and things that are deeply human, but also that aren't merely animal, but are actually have spiritual dimensions to us. So I guess that's, I think, is the thing, is maybe to read some Heidegger with them. Yeah.